From the beautiful studios of Way Happy, this is Mr. Meyer, 1-2, properties of real numbers. Now, properties of real numbers, we're going to teach you two right here, and that is the inverse and the identity. So an identity, as you can see right here, the identity property for addition says what number could you add that would not change the number that you originally had. So that's called the additive identity. Same thing for multiplicative identity. Multiplicative identity is what number do you multiply in order to keep that number. So that is called the multiplicative identity. So as you can see, additive identity is 0 and multiplicative identity is 1. Now, inverse is the opposite. If you have a number, what would I have to do to get the identity? So an inverse, if 5, as you can see here, 5 is your number, what's the opposite that you would have to do in order to cancel it out so you get the identity, which is 0 in this case for additive? Or multiplicative is what's the inverse? What would cancel it out and get you the identity to get me back to 1? So you can see there, that is the inverses and the identities. You have one for adding and you have one for multiplying. All right, what about commutative property? I know this is you've seen a million times, and I just want you to make sure that you continue to think about the commutative property. And the way it works is the numbers actually change their order, right? So if you see the numbers in a different order, then someone has used what is called the commutative property. So, and it allows you to do that. You're allowed to do that with addition. You're allowed to do that with multiplication. I don't know. Are you allowed to do it with subtraction? You think about that. What about the associative property? Associative property is when you decide that you are regrouping things. So notice up here when we had the 7 and the 11, they stayed in the same order from one side to the other. But look at, this one's not very well, but you can see this is 5, 3, 7 and 5, 3, 7. Notice their order stayed the same, right? So here you have in commutative, they changed their order. It went 7, 11 and then 11, 7. In the associative, we went from 5, 3, 7 to 5, 3, 7. We stayed the same. We just regrouped that order. And then distributive property is probably everyone's favorite. That seems to be one that people like. The distributive property says, hey, you need to distribute the number out front. Now, I could have added the 8 and 2 together first, got 10, and then multiplied by 5 and got 50. But it doesn't matter. And notice the distributive property could also work in the back of the parentheses. It's a multiplier to a parenthesis, and it has to go to both things. All right, there's all that vocab out of the way. What the heck can we do then for some problems? How about we find some inverses? So I ask you, what is the additive and multiplicative inverse of each number? What is the additive inverse of 12? Well, the additive inverse would be, what would cause that? What would you have to add to that to make it 0, make the identity? And so for adding, you would have to add a negative 12, and that would be called the additive inverse. And the multiplicative inverse, that inverse is what would you multiply in order to get 1? And I would multiply, oh my gosh, a fraction. Hold on to your hats, 1/12. Oh my gosh, that's so scary. But that is the multiplicative inverse. What about 9/4? The additive inverse, what would you have to add to that to get it to be 0? I would have to add negative 9/4. So again, just taking the opposite of the number. If it was negative, you would take up the inverse would be positive. And what about the multiplicative inverse? Oh no, what would you have to multiply by in order to get that to be 1? I would multiply by 4/9 because the 4s would then cancel, the 9s would cancel, and I would be left with 1. And there you have additive inverse, multiplicative inverse, and what gets them to the identities. Now, what about properties? Which property do you see here? Well, look, I have a 2 times a 3.9. And that's equal to a 3.9 times a 2. Notice the order changed. It went 2 times 3.9, and then it went to 3.9 times 2. The 2 didn't come first. So somebody switched their spots. They like commuted, right, from one side to the other. Oh my gosh, that must be the commutative property, and it was multiplying, so we're going to call it the commutative property of multiplication. And over here in B, I see, looks like it was going to be set up as distributive, but it's not because they didn't distribute the 3 all the way through. What they actually did was leave the numbers in the same order as always, 3, 2, 8, 3, 2, 8, and they just regrouped them, which was legal because it was all multiplication. And so therefore that is called the associative. They regrouped them. They made them new associates. So the associative property, be careful the way you abbreviate that, the associative property of multiplication. Nice. All right, let's ask you a question, and I will be right back. All right, nice work. Now, you really gave a good effort on that one. I'm very proud of you. All right, example 3, we're going to use mental math. So you go out and somewhere there's a 5% tax, which around here it's kind of a lie. It's like 9.5%. But we'll say somewhere else it's a 5% tax on a $42.40 purchase. So how much is the tax? I want you to just do that mentally. It's kind of hard. I mean, you would have to do 4240 times 0.05. You'd have to do that in your head, and that's probably not the easiest. But if you have some number sense, you know that 5% is half of 10%, and you know that taking 10% of something is pretty darn easy, right? Because like if I want to take a half of 10%, I mean, if I want to take 10% of 4240, that's just $44.24, right? That's 10% of that. And now I can cut that in half. And you know why that is? That's the associative property right there saying, hey, I don't care how you group them because it's multiplication. So now I take half of $4.24. That's $2.12. There is your answer. Just out of curiosity, maybe you had half and you had the 10% and then you had 4240. Maybe you wanted to use the commutative property and switch these two. So you had 10% of half of 4240. And you'd be like, all right, what's half of 4240? Half of that's 2120, 10% of 2120. And then you take 10% of that, you're like $2.12. So very cool. With a little bit of number sense, you could understand that I can kind of do stuff in different weird orders as long as it's legal, as long as it's multiplication. I can kind of do it in any order I want and pick the easier order. Don't make it hard on yourself. Pick something that's nice. All right, last one, example 4. Classify each statement as sometimes, always, or never true, and give examples to support your answer. All right, so first thing I'm going to do is I'm going to be like, all right, A times B is A. Ooh, so if B is 3, so that's like A times 3 is equal to A. When is that true? Is that true all the time? Well, no, because I plug in the number 7 and I get 7 times 3 does not equal 7. It's 21 equals 7. So that didn't work. So I'm right now thinking it's never true. Is there ever a time it's actually true? Yeah, right. 0. I bet somebody's saying 0 times 3 does equal 0. So that's a good one. So I'm going to go ahead and say sometimes now. It wasn't always, and it wasn't never. It was sometimes. I had to think for a little bit. All right, what about this one? Is that always true? Well, let me think. The distributive property says that this would be 3a plus 3, because I'd have to distribute to both things, is equal to 3a plus 3. Oh, yeah, it doesn't matter what a is. It'd be the same. If you want and do some more math, you could be like, hey, look, I could subtract the 3's and get 3a equals 3a and then divide by 3 and get a equals a. But in this case, it would be always true. I don't think I can think of any chances. Maybe we should think of what happens if you plug in 0? Well, you'd have 3 times 0 plus 1. Does that equal 3 times 0 plus 3? And let's see, that's 1 times, that's 3. And on this side, it's 0 plus, yeah, that works. So 0 is usually a pretty tricky one. I wanted to make sure it worked. I'm going to go always. Always. That's it. Have a great day. Stay happy. I'll see you tomorrow.